Hey guys, so welcome back. Well, we're working on this Sencore Mack CRT tester and beam builder. This is used for testing and perhaps rejuvenating picture tubes in vintage televisions. This project has turned into quite an adventure in repair of a vintage test equipment, and it's quite a journey. This video is not a how-to, but really I'm just showing my experience trying to repair this thing so we can use it again. I've done some editing. I've edited out quite a bit of time, but I've left the main points and I've showed my errors. So you'll see the progress and how I'm finding my way out of this. Some of you more experienced guys may be yelling at the screen early on, but just stick around and see if I can figure it out. So in part one, we made some progress getting this Mack to doing its core functions, but now the issue is dealing with the meter, which served an important function and is not working. So let's find out why. So let me replay just a bit of part one to get reoriented, and then we'll launch into part two. So grab a beverage and some snacks, and let's see how it goes. I like it. All right. So what do we got? Well, we got the filament voltage is working. This is working. The line voltage is working. Like I said, I'm gonna let this warm up for a while before I finally get that calibrated. It's probably pretty close though. And then I'll go through and check a few other things. But that's good news. We'll figure out what we're going to do about this. Like I say, I may want to take it apart and take a look at it. But as it is right now, we're getting somewhere. Okay, I think that we're done with checking the line voltage and checking the filament, at least for the 6.3. And I think now what I can do is I think I can go in there and make a zero adjust on, I think it's the HK shorts setting. I'll do that. Let me get some other things set up and we'll see how we're doing. But I'm thinking about going ahead and putting this filament adjust in. I guess I should go ahead and do that. I'll do that first. Yeah, so it's next day. I got to looking at some of the video that I've already done for this. I try to kind of compile it as I go, because otherwise it's just too daunting. One of the things I noticed, I was talking about going ahead and installing the knob and the filament adjust knob. One of the things I noticed is that when I was getting a good test in terms of reaching 6.3 volts for the filament using this, I didn't really notice what was going on here. When I edited the video, I could see it. This needle was over here somewhere. Okay. Remember that half scale on this would be full scale on this. Now the 6.3 or the 6 volts on the filament set is right in here. Okay, so that's less than halfway. So this should be more like around 4 on a scale to 10, you see. So the meter, the signal that's going to the meter is not correct. So I want to address that before I go any further. There is a troubleshooting chart for that in the manual. Okay, sometimes switching this is what you're doing is you're adjusting how the scale of the meter would go. This part here is affected by this little circuit right here, these rectifiers and these resistors set up in here. So I know that I checked these when I checked this board, but I may need to check it again. Okay, so I've gone through and checked those other parts that troubleshooting is referring to. I was checking this capacitor, I was checking these resistors in here, and there's a couple of Zehners down inside of there. I checked all these, they all seem to check fine. I've done tracing from the meter leads through these Molex connectors, through the wipers to these different points. They all seem to check fine. They even go through the test versus rejuvenate switch, and it all seems to be working okay in terms of continuity. Okay, so I got the board put back in. I've got the new filament set switch in. I've put a knob on it. I think it looks really good. I've got it centered where halfway is right there. And we can see how this thing works. Let's see, I think I get power on. Yeah, let's switch it on. Okay, power's coming up. And you'll see this is the output of the meter. Let me go to line volts. So it'll still say 50, which is half scale of the 100 microamp scale, and then and you see we already got filament voltage here, so I'll go ahead and adjust that to be to 6.3. This is working like it should. Turning it up. Excellent. So there's 6.3 going into a 5 watt 10 ohm resistor. And it settles in pretty nice. Okay, so if I switch this to filament set so that the meter would work for adjusting this rather than having to have this hooked up, I go here, and a while ago it was not showing anything, and then it woke up, and now it's at 100 microamps, which would be full scale on one of these. So that's still not working right. I'm not sure what's going on. I'm not satisfied. So I'm going to keep looking into all of that. I've been wondering about a few things. One I've been thinking about is, does this have a different impedance than this? Or, you know, it doesn't have just a stronger spring? I guess not. It may have a different impedance in it. So I'm wondering if that would throw off some of the circuit. There's a shunt in here that engages when you flip off of these first two settings. And I've checked the shunt, and it is right on. It's a 1% resistor, and it's right within 1%. So that and all the switch settings seem to be okay to me. So I'm not sure why this, you know, and this aren't really doing what they're supposed to do. I'm glad that I got this worked out. So we've got line voltage working, we've got filament set working as far as this goes, but the meter aspect of this isn't working. I think what I want to do is I want to open this thing up and see what's going on with this. I checked its impedance a little while ago, and it was over a meg. That can't be right. So I'm going to open this thing up and see what I can see inside. Okay, I have the meter out. I'm going to check its impedance here just to see what it shows. I found that when I did a check of the other meter, that the meter would read the current that was being applied by the voltage tester for the resistance. See, this is reading like 3 meg, 7 meg, 9 meg, 14 meg, 3 meg. So that's clearly crazy. Let's look at this one. This one is it's about 430, 425 ohms, and you'll notice when I do the measurement here, over here and here, you can see the meter come up as the resistance is red. So, you know, we're into micro ohms here, or rather microamps. So there's the current being used to test resistance of things. Anyway, so what I want to do is we're going to open up this Sencore meter and see what we got going on. Made by Dixon. Okay, so I'm going to get started on that. There's a number of things I want to check in this movement here. So let's see if I can get the right equipment together. That made a click. So that is moving the hard stop, which is like a little white bumper in there. I don't know if you can see it. Okay. Okay, the screws are out. So I'm going to remove the faceplate, the dial cover, the dial face rather. I had put some sticky double stick tape on here, which has never held until now. Okay, so the faceplate is off, and here we can see the movement. One of the things I'm looking for are the counterweights on the, see, is there anything loose in here? Okay, that is one of the stops. There was 2 stops, I thought. Yeah, I see it. The stop is here. Okay. All right, so what we've got a permanent magnet, and we've got a coil in here that gets current going through it, and that has it react within this magnet. So let's see. Let's just simply come out. It's loose. Okay, it's loose on these small screws. Sorry. It's loose on these small screws here. So these are the ones that have been loose and allowing this to move around. Let me get these out. The magnetism is quite strong, I guess, from that horseshoe magnet that's in there. Okay, we had a standoff fall out. And there must be another one behind this one, indeed. So that one comes out. So we should be able to extract this. We've got leads that allow us to pull it out of the case, like so. Okay. Let me grab the standoff before it gets away from us. It's on the floor here, just a moment. Okay, so here we can see the movement at last. One of the things I was wondering is, did it have a shunt inside? Was there a resistor in here? The answer is no. But what we do have is a broken wire. Hey, actually I think that's a very positive thing. This may have been coming cold and may have been causing our fluctuating values. And that looks like something I can easily resolder. I am going to take some time and I'm going to get that resoldered and do my best to not mess up anything. So let me get that set up. I want to do it off camera, and then we'll see if this thing has free movement. I think that looks like the needles are relatively balanced. I don't see there being like missing counterweight. Well, there might be. There might be. As I look at it, I see. Let me show you the counterweights here. Well, let's see if we can find any. All right. So one of these tangs had been bent down. I tried to straighten that back up, so that this provides some loading on this little hairspring that's in here, which is similar to on a balance, a watch balance. If you can see the little hairspring in there. I can't tell if you can see it or not, but there's a small hairspring in there. And that's what drives this back and forth. And it looks to me like everything's connected. Everything seems to be working okay on that. So that's good to see. I see a piece here, which I'm assuming is the counterweight for when this is hung in this, when this is hung in this position, so that it's balanced like that. Okay. So if you imagine it like a sword, right? You got the haft, and then you got the hand guard, and then it sits here like this. Vertically, there should be weights on both sides of that piece, and I see a piece here, and I do see a piece there. I think all the counterweights are there. I've got another hairspring in the back. So, I don't know if you can see it. I'm going to do this when I'm not damaging something, can't see what I'm doing. Okay, so there is another, beg your pardon, there's another hairspring on the back right here. I can't see if you can see if it's focused or not. Yeah, another hairspring there. And other counterweights and everything here. So that all, I'm going to assume that's all okay, and that the biggest problem I've got is I've got a broken lead that must have been coming cold connected, and because the screws that held this in had come loose, perhaps this was pivoting around and caused that wire to just come apart, and that was causing our weird intermittency. I'm just going to guess. I'm definitely not going to guess. I'm going to hope. So I'm going to take a lot of time, like I say, off camera, and see if I can resolder that connection. I'll bring you back in a bit. It's right there. This wire goes right there. Right there. Okay. Okay. So I'm going to pass this through, and then I'm going to strip the other lead and attach it to that. Just the idea of trying to get that multi-strand through a little hole, it just wants to, you know, it wants to fray open, and it's just, it doesn't make it any easier to have to deal with that. So let me try doing it this way. Okay, I hope you saw it. But you can see the final result there. Well, it's not the final result, because now I need to attach the multi-strand here to that. Okay, I'm thinking that'll help. Okay. Okay. Back you up to here. Still reading almost 2 meg. That doesn't make sense. I'm going to take a more close look at this. So it makes me concerned this thing has been burned up, and we've got a connection here that just doesn't want to make. It's on the order of 2 megs. And the meter needle is not moving. There's a cold connection in here somewhere. Well, I think I've done my best trying to get this movement back into operation. I've even bent the needle a couple of times by accident because I'm ham-fisted. But anyway, I think this thing is just about done. I've tried using this, back up a little bit, I've tried using this other meter some, and it doesn't seem to be working perfectly with me. So I decided, let's do something different. Here is a 100 microamp meter, which is what our device is looking for. Let's get this thing out and we'll see how this does. So this is set up for 100 microamps full scale, so it should behave like the one that was in here. And I'm going to hook this up like we did this one, and we'll see how it behaves. So let me rearrange all this stuff, get this poor guy out of the way, and then we'll see how that's happening. Okay, so I'm finishing getting all this connected up so that we can do some of these tests and see how we do with this meter here as opposed to this one, and opposed to the one that came in the unit, which I've got somewhere else. All right, so I've got this set up to measure 115 volts here. We're going to be looking at this to go half scale, which will be at 50 milliamps, right? Microamps, sorry, when I'm at line volts. And then what we'll do is I'll go ahead and put this on 6 volts for the filament. And we'll switch it to fill set. And then I'll be looking at the AC volts here, which is across this 10 ohm 5 watt resistor. And then we'll see if we can get this tuned in. And so what I want to do is talk about what we're expecting to see or hope to see before I do this, because as soon as I turn this on, it starts firing up the filament and this starts getting hot. So I just don't want to keep doing that any longer, and we have to. So one of the things I did was, reaching over here, so I took the scale and I used some double stick tape and taped an index card in the back of this. And then as best I could, I drew lines from this edge and this edge down to get the intersection point, which should be the center point of the meter movement. All right, and I did that by just putting a piece of, I don't know what I'd do with it, I have a piece of plastic that I just laid over this, clear plastic, and then used a scale. I used that so make sure I didn't get any scraping on that. And then what I did was I then drew a line from where this has the little red mark for 6.3 volts. Can you see that red mark? Well, I drew the line, and that is for 6.3 volts. So it also essentially is right there at the 110 volt mark right here. Close, right? So then the question is so what do I expect this meter to read? Now remember, when I switch this, it kicks in a different resistance through here, a different type of shunt, so it'll change this. So the idea is, what do we expect this to read if this shows what the reading would be after the shunt? So we do just a little bit of dimensional analysis, and I'll show you that here. So basically we say, all right, so if we want to know what the volts will read on 100 amp, this should be amp, scale, full scale, then let me change that. That should be amps, right? 100 amps full scale. It should be equivalent to what the 6.3 volt reading would be for a scale that goes to 15 volts on the scale that the 6.3 is on, okay? So we're basically looking for a ratio. So that means that, just do a little bit of algebra, so that becomes amps full scale, that becomes amps full scale. So now you've got, the 100 comes over, we've got 100 amps full scale times 6.3 volts divided by this 15 amps full scale. The amps full scale cancel out, you're left with volts, and if you do this multiplication, you get 42 volts as a reading on that scale. Let's see if that makes sense. So we go to 42, then that would be about here, the first mark. These are 2 volt per mark. See, there's 40, there's 50, there's 60. So it'd be the first mark past 40. So that's what I'm expecting to see, and that would be pretty much what you see here. So that makes sense. So what we're going to do first, though, is we're going to do the filament set. We should be able to get this at 115, get this at 50 amps, microamps, and then we'll switch it, and then we should be getting this to be, by using this filament adjust, we'll get that to read 42 microamps on this scale, and we'll be checking to see if it says 6.3 volts on here. Okay, now we're going to get started and do all that. So I think I've got everything okay, no shorts, right? Okay. Can you see this okay? I want to get it away from that long lead right there. Okay, you can see that pretty good. All right, so that's on. Let's put this on volts AC. That's off, turn on. I'm at 120 volts for this. All right, we'll turn this on. I'm watching my ammeter. Okay, we're good. Okay, so line volts, we want this to be 115. Now I probably want to let this settle in a little bit. But let's just see if we're getting something close. Okay, we're reading a little high, and that's okay. I'm not surprised that we're getting something different. So I'm going to reach back around there and adjust that variable resistor on the power supply board. Okay, here it is. And we need that to go down to the wrong way. And there we go. How's that look? That look pretty good? Get you out of any parallax here. Okay, just a little bit more adjustment. I'll do this again after I've let it kind of settle down, but we're just going to see if we're obviously getting very close here. Okay, that looks pretty good. All right, so what we want to do now is we want to switch this to fill set. Got this set at 6. Now we want to go to 6.3 and see if this reads 42. Okay. It's moving the wrong way. Okay, that's at 6.3 volts going through that resistor, and we're reading almost 50 milliamps again. So that's not quite what I expected. Get this corrected back. I don't think that's going to make any difference. Not enough to make any difference. Okay, so I'm going to check to see if there's anything in the troubleshooting about why this would read one way versus another. Another thing that I was noticing is that if you go through the schematic on this, there's a number of things that affect this measurement. And let me just show you what some of these are. So if you look on here, I can't show you all of this, but basically it has to do with, it's affected by these switches in here. And so these switches here are the ones that switch to beam builder. So if I switch off, see that kills it, and I come back, it comes back up. The other thing I noticed is that some of these wires in here were a little iffy. See? So I need to go in there and check out those pins and make sure they're reading okay. And I need to make sure that some are contacting and all of them are contacting, not just some. So to see if that would have anything to do with what we're getting here. So I'm going to go run through all those things and see if we can get this to read any closer to 42 when this is reading 6.3. Okay, so I've been busy. The video's getting kind of long, and I just wanted to get some progress and not just be filming everything I'm doing. So for those of you that are hanging on there, raise your hand in the comments. Let me see who's still diehard on this. What I did is I took this PC board back out, and I've got it kind of connected right now because I wanted to show you how I had that done. But what I did is I pulled this thing out and I checked every resistor on here. If it didn't read easily, I lifted the leads on these things, and particularly the precision resistors out in here. I lifted virtually all of the precision resistors to measure them. And so I've got pages of actuals, should be's, the component, the should be, and the actual that I read. And I found some interesting things. One of them is, if you remember, I had one that was installed as an incorrect component. I found a couple of more of those. And I found a couple of them are precision resistors. There was 24K 2%. They had installed 24.7s 2%, which puts it out of this range. I don't know if that makes any difference. I lifted them to see what they were, and they're both measuring 25K on those, so they're out of range. I don't know if that would actually make the difference, but if they're 2% resistors, I figured it must be important, right? I don't have any more 24K 2% on me, but I did have some 22K carbon comps, and we know how they are, right? So I thought, well, let me see what we get on these things. This one's 24.3. That's within 2% of 24. And the only other one I have is this one. Come here. I don't tend to use these because they're off, but they're kind of off in the right direction. 24.0. I think I'm going to put these in the replace those 24.7 precisions and let these act as 24K precisions. I can order more of those later, but this will help me see if this has any kind of impact on the meter reading. I don't think it will, but I've been looking at some other things here. So let me show you the simplified schematic for it again. One of the things I did, which was helpful, is I went through and looked at every component in here and wrote down what its value was per this sheet, because the parts list in here does not list every component. and it will tell me what kind of wattage it takes and what tolerance it is. The watts only if it's more than a half watt. But it's helped me find a lot of other issues that I need to check on, such as the bias resistors that are on the bias switch. You know, or they're not quite where they need to be. I may have to replace those as well, but one thing at a time. Anyway, so I started going through this, and so here's the simplified filament circuit. All right, so here is the meter, and this is the shunt circuit right here. So when you're measuring the line set, this is switched out and here. And so this shunt circuit is out of the circuit. And see, does that make sense? It should be. This shunt circuit kicks in when you switch. This is the front panel switch that goes between test and beam build. When you go to beam build, it switches this element out. But what I'm looking at here is this element here. If in the troubleshooting it says if you're having problems reading this meter, you need to be looking at this items right here. I went back and checked these diodes. They do check okay. These are switching diodes. They do test okay in terms of the, you know, they're not shorted. I might replace them. I got some replacements. I might change them. But these are the two precision I'm talking about. So I'm thinking about changing these out and see what they get. Now I was looking down here about how I could measure, you know, through here, because I was looking at these switch positions, and I was wondering if this switch has higher resistance due to, you know, oxidation of the silver contacts that are in here, then that would make this shunt a higher resistance, which would have higher current going through the meter, because the shunt needs to be sharing some of that current. So my problem is trying to measure what this is. As I did it before, I also have a parallel resistance going on through here. So I think what I'm going to do is, I want to go back into here to this 1.2 precision resistor. I think what I'm going to do is I'm going to lift one of these leads. It may be here or here. I'm going to lift one of the leads on the 223, okay? And then that'll break the circuit going to the parallel. So then what I can do, I'll disconnect the meter. I'll hook up my ohm meter to either this or I guess on this side be better. And then what I'll do is I'll measure resistance from here to the positive terminal of this capacitor. And I'll see if switching this, you know, gives me different resistances, and then maybe I could look at maybe trying to clean that switch some, and then I'd know if that was doing some good. So I'm going to do that now and see if that helps. And then later I'll probably go in and replace these two with those two carbon comps I have, just to see if it gives me back into the zone. I'm going to do this first. We'll see how that goes. Okay, so this is going through just the shunt circuit, which is supposed to be 480 ohms. So as you can see, it's 481. So any residual resistance due to the switch and so forth is just not really 1 ohm is nothing. So if I go to the other side of that resistor and kick it in, so that's 1.2K. I've got it lifted right here. So it's reading right like it's supposed to, and so the resistor and the shunt system. So this resistor and the resistance of this switch, and even all the way up through here, I have this disconnected, is fine. So that's not my problem. I think what I'm going to do is substitute out those two resistors, those precision that were in there, the 24.7s, and put in those 22K carbon comps that measure 24. Put those in and we'll see if we get any difference. And here you can see where those 24K precisions, I've lifted them up so that I could do the measurements. So I'm gonna replace these two guys, and we'll just see if I get any difference. Okay, I know this looks like heresy. I've replaced those precision resistors with these carbon comps because they're so far out, they're where they need to be. So basically I've picked them to go into this position. Now I'll put this back in the board, and this board back in the unit, and we'll see if we get anything else. The other things I did is went through and reflowed a lot of these pin connection points, not all of them, but I looked at them very closely to see if I could see anything that looked like a circle around them, whether the the solder joints were getting cracked from being connected to these things. I went through and touched all those things up. These are the ones I lifted and tested all these. These are all spot on. Anyway, so we'll put this back in and we'll just see if we get anything different. I have not changed those diodes. They are down in there. I might do them next. I feel like I'm kind of grasping at straws here, but we'll check it out. We'll see how it goes. At least I'm following a troubleshooting, simplified schematic and changing out different things to see if it gives us different performance. So I'll put this in. We'll see how it does. Okay, I got all the boards back in. Got it hooked back up into our test setup that we have here. This is the voltage from the line volts. This is our meter that we want to see straight up and down at 50 microamps. I keep saying milliamps. Microamps for 115 volts in. And then this is measuring the voltage across our load resistor here, which is 10 ohm, 5 watts. Okay, and this is coming from the filament supply. So let's get this kicked off. Okay, we got that set, probably about 117 or so. I'm going to kick on the power now, watching amps. Yep, just making sure I didn't short something. Okay, so I have this set on filament as 3 volts. So let's put this to 115. Okay, close enough, right? And now I'm going to switch this to line volts. And, okay, we're going to make an adjustment. Just tune that in just a little bit. It's silly to be doing this. I don't know. I don't know. Just I guess my OCD kicking in. Okay, so let me tweak our resistor here on the power supply board. Okay, it now reads 50 microamps. Okay, so now what I'm going to do is I'm going to take this to more of a traditional line current. Let's say it's 120 volts. Expect this to read higher, which is fine. It would show higher on the regular meter. Okay. All right, so now what I'm going to do is I'm going to switch this to fill set. And I'm going to turn this to 6.3. So I go to the 6th position and turn this up to 6.3 on our red meter here. I can already see we're too high. 6.3. And right back to where we were. So that didn't help a bit. I'm going to put a meter in series with this and see if I get 50 microamps. Should be able to do that right here. Take this to 50 microamps, put this in microamps, and then I'm going to put this in series with the meter. Should put us into series ammeters, right? Oh, come on. That's interesting. The impedance of this has dragged this down. Is it that shunt is sized for that particular meter that was in here, and that with different meters you may have to change out shunts? So does that mean I need to put some impedance on the meter line, or that 480 ohm resistor needs to be changed? If I put it on the line, it'll affect all the measurements going through this. If I put it on that 480, what do you guys think I should do? You think I should try putting some resistance on that shunt line, increasing this resistance here? Let's see, this is putting impedance on this lead, dropping it. So really you'd want this to go down, wouldn't you? If I put more impedance on here, I'm shifting the current onto this line. But I don't want to affect the meter for everything. So what I want to do is have more of it go this way. So what I need to do is reduce this 480. I'm going to try reducing the 480. I'm really getting into some weird world here though. Anyway, I may try that. The difference is this meter maybe. Okay, just because I thought somebody would be interested, I took the meter out of the circuit and I'm using this just strictly in the ammeter mode, coming directly from the leads that would go connect to the meter here. So it's not in series with this meter, it's by itself, just to see what we get with it. So when I have this in line volts and I've set this at 115, this is reading near 50 microamps, which is kind of how we had that other one calibrated, right? It was to be kind of in here at 50 microamps. But when we switched this to fill set, this went to 50 and not 42, which is where we know we need to be from the scale that was on here. But now when I switch this to fill set, well, first I'll bump that up to 120, just so we're repeating it like it was. Okay, so we're at 120. Now I'm going to switch this to fill set, and this would be set for 6.3. Look at this. This has gone to 100 microamps. This was at 50. Let's see. So I believe that means that the impedance of this is much less the impedance of this. And so the shunt circuit is forcing more of the current to go through this meter than through the shunt circuit, where that 480 was. So there is a difference in performance of how many, you're gonna, in meters for how much impedance you get. So maybe I need to have a correction for the shunt circuit for this one. It's interesting that in the discussion here, they talk about that resistor here as being the calibration resistor, the calibrating resistor. Okay. If you want to make it calibrating, I'd make that a variable resistor, right? So you can tune it in for whatever meter you got in there. Instead, they put a set value in there with a, what was it, a 2% or a 1%? It was a 1%. I think a VR would have made more sense. It's interesting. You sit at your table and you look up at your shelves and you're kind of thinking with your mind being open. You notice something. Are you thinking what I'm thinking? I can see down here it's full scale 100 microamps. I don't know if you can see that, but I can see it. That is what we have here. Bear with me a second. These are made about the same era. Are you thinking what I'm thinking? If you are, I'm sorry. I think this is the same meter movement. I'm going to pull the meter movement out of this Super Cricket, and I'm going to put this faceplate on it, and I'm going to load it into this. Well, I'm going to see how it behaves. I'm going to take this out and just see how it behaves in terms of looking at the scale. I may not even take it out. I'll just open it up and get to the terminals, and we'll see how this thing behaves and see if it looks more like what we want. If it works, I think I can cannibalize this movement, take this movement out if it even has the same frame, and I'll just change the scale, and we'll load it into the the Sencore CR31A, and then I can either just wait and swap it back to here if I ever need it again, or keep an eye out for a spare mirror. I'm getting ahead of myself. Let me just open this thing up, attach the leads to this, and see if this meter has the same impedance as the one that's broken, and see how it does. Okay, so I am now inside of the mighty Super Cricket, and there's our meter back there. It has a number on it. I suspect that's just a date code. If I look at the design of this, it looks a little different. Let's see, it should be like this. It looks a little different. It might not be the same, but I can pop the meter maybe into here. It looks like it's got the two lower screws. It might be the same dimension as here. So I'm going to disconnect these two terminals. I'll mark them so I know which ones, well, they're red and black. Okay, and then we'll hook this meter up to our CRT tester, and we'll just see what it does. Bear with me. Let me get this set up where we can look at it. Okay, so I've got the leads that go to the meter from the Super Mack going into the back of the Super Cricket attached to the terminals for the meter. I've disconnected the Super Cricket from this meter and I'm jumping it with these jumper leads that are here. I set the meter from the Super Mack here just so we can kind of get an idea where we're supposed to, kind of things we're supposed to be seeing. All right, I've disconnected the line testing here. We don't need that. But I'll start off here. Well, should I do that? Let me get that set up. Hang on. Okay, so we've got the power hooked up to here. I've got it turned in to say about 115. We're going to have to recalibrate the resistor possibly to match this meter impedance. All right, so let me get that about 115, and we want it to be half scale. So let's just see if it responds. Let's see, we're in line volts. Fingers crossed. Oh. Okay. Get this back up to 115. And that is, I think that's virtually straight up and down. I'm happy with that. Okay, so that means that this other little meter over here was doing fine when we were just checking line volts because we weren't using that shunt circuit, which is based on knowing what the impedance of this meter is, or whatever meter is I put here. Okay, so now what we want to do is see if I switch this to fill set and set this at 6.3, does it look like it would go, like we said before, we have to, well, maybe we can do a ratio in here and see if it's getting right. See if that's 50, then this would be half of 42, which would be 21. We'll see. All right, let's switch it to fill set. And then we'll set this at 6.3. See, am I in the right place? Yeah, 6.3. I won't say it's, is it, well, it might be. Okay, 6.3. And this is, guys, I did not pre-figure this out, okay? That's pretty close. That's pretty close. Reach down here, adjust the fill set. Yeah. So that's supposed to be like 21-ish. I'll have to do the conversion. That's sitting at 6 volts into the resistor, the load resistor. I'm coming back up to 6.3. And that's 6.3. If we back up and compare it to the gauge that's down, the meter down below it, we want to be right on that little red line that's right here to the right where it says 110. There's a little red line above it. I think we got a winner. I think we got a winner. Okay, so we got two options. One of them is that I cannibalize the Super Cricket to get this meter out and use it again, which I might very well do, and then just look for a replacement meter someday. And then if I ever need the Super Cricket again, I'll just hot swap it. I'm not likely to need them at the same time, right? Or I might look at putting a VR on that shunt path and tweaking it in, but still that other meter won't work. It won't fit. So I may just do this. I'm excited. I think this is going to work. So what I would need to do is take this meter out, look at fitting it to this housing, which is the housing that came out of the Super Mack, see if it'll fit, and then see if I can take that scale off and put this scale on, and then fit it into this case. That would be the challenge. Okay. Yeah, I think it's got some strong double stick tape in there holding it. I'm going to have to be careful. We have to go in there with a blade and see if I can slice it. This feels like a different type of material. This upper pad is like the foam pad, foam in the middle with sticking on both sides. You feel it kind of coming loose. I don't know, but this one feels a little different. Some of you purists must be getting really freaked out by this. It'd make a great thumbnail picture, wouldn't it? This man destroys this meter for you to see with improper tools. I excel at that. Okay, so we're through on this side. Go back to the other side, and I think we're about almost done. Yeah, the dust from that is just falling everywhere. Okay, we're out. Yeah, goo. Okay. I think we got a chance. Yeah, this the mounting holes don't match up for this, but that's okay. Need to change the screen anyway. Let me get from the Super Cricut out of the way. I'll clean all this dust up, and I'll bring it back in a second. Okay, so we got to take the Cricut meter and dial out of this case, or at least out of this part, and mount it into this housing that has the screws necessary to fit here to this body, and put this faceplate on it. It looks like to me it's the same meter size. I could be wrong, but we'll just see. We'll see how it fits. I sure hope it works. Okay, so I got to get the cover off to get to those two screws that are there. And what it is, you got screws from both sides that go through a coupling nut. It's got female threads on both sides that match with these screws here. And I'm hoping those match with these here. They look like they do. Anyway, one way to find out. Let's get in here and see what we got. Okay, the front just fell away. I'm not going to touch that face. Here's our meter movement. Okay, so I think the next step I'm going to do is I'm going to take these screws off so that if it doesn't fit, I can put it right back into here and not mess with this front part. All right, we'll see if that will work. Okay, I know there's a long screw there, but let's just see how we're doing. I can tell. Okay. Okay. Everybody be calm. Everybody be calm. It came loose of the coupling nuts. Okay. So that means it should lift out, right? So I want to transfer it from here into here. Can I do it like this? Oh man. You're not nervous, are you? You're nervous, not me. I'm not nervous, you're nervous. Right? All right, so take this. Don't be nervous. Everybody be calm. Okay. Well, it looks different. Bent the needle a little bit, it looks like. Man, that was swappy. Okay, getting my composure back here a little bit. So we want these two screws to push out here. And we want them to come up through here. Like that. And like that. Okay. So if I remember right, which one was which? It wants to hang like that. So let's put it in that way. That looks like that's opposite from the way the other one was. Well, we'll hook it up, and then if need be I can reverse the leads, but let's just see if this thing's even going to go in here. So what I need to do first is get these brass screws to go in. All right, let's see. Oh man, let me see. These screws are on the faceplate side. Okay, so then this needs to go in where, okay, the brass screws need to go first. Oh man, I am not cut out for this kind of thing. Okay, let me catch my breath here. Leaning on the needle, I don't like it. Stop doing it. I'm touching the needle, quit doing it. I'm trying to get the nut on here so the bolt doesn't fall out. All right. Okay, so I got the bolt on. Now, let's see how much I moved this. Okay, so now this. I'll just use gravity to help me. Should have made a mark on these heads so I was sure which side was positive. I may have these backwards. Okay, so now I'm going to see if these screws will line up. First first one. So one is in. Now the trick is, where the other one go? Go in there. Okay. I don't know if it's going to fit. Well, so far it's fitting. So far it's fitting. So the challenge now is to change these two faceplates out. We've got a couple of travel stops here that need to be set correctly. The tips of these are basically on the center line between the two holes. So I'm going to use that as my go-by, as the tips need to be basically along that center line between those two holes. Okay, this goes on. Y'all wishing me luck? Okay, it's loose. I think the other meter had been apart before, because all of this was loose. Okay. The question is if this meter's bent, the needle's bent a little bit. I think it is. I need to try to see if I can bend that needle back down. Okay, Mr. Hamfist is going to see if he can get that needle bent flat again, if you guys can see my skill at bending that needle. Alright, so let me see if I can bend it back. I've got a popsicle stick here to be kind of a way to support it up by the hub, because the bend is right over here. Okay, just a minute. Let me get myself set up here. Okay, so now let's be about like this. Might not be able to do it in the case because I can't get enough deflection. Oh, I think that did it. That'll do. Are y'all impressed yet? God, I'm terrible at this. Okay. So now we get to try to put the other face on. The screw goes into here first. Okay. So we pass the screw through. And then we use the little travel stop. Stick it on there for now. We'll put this coupling on. And then just kind of get it held on there for now. Okay, so now I need to take the other one off. put the other one off and put it on, and then put this on here, and then thread the other one into the other side of the coupling, and then jam the two screws together, which should tighten up on where these travel stops are. I need to go ahead and do that ahead of time though, don't I? So I can go ahead and get that kind of lined up. I've got it about right. Yeah, that's actually pretty good, right? Okay, let's do this other one. Okay, faceplate for the Super Cricket. Now this, yeah, and the other one, I don't know if you noticed it, but the screws were different lengths too. Somebody had been into that meter and tried to fix it. And we know that we had a short that went through the filament line. And that must have been what caused a lot of this damage at the beginning. Okay, now this goes on like that. Edge it down, okay, to that there. Okay, so now what I'm going to do is tighten that down so that doesn't move. Right here. And in here. How are we looking? Not too bad. I think that's pretty good. This one might be a little low, but that's all right, because we'll tune it in. As long as they're not blocking it from going as high as far as it should. This one might be a little, it looks okay. All right. So now we need to slip this in and then thread those screws into the base of this. All right, so let's see if we have any luck doing this. Okay, like this. This around. Come on, baby. Line up, please. Line up, please. That's screwed. Okay. Down. All right, so now can't tell if I'm on it straight or not. Everything being magnetic is kind of a pain. Okay, that worked. All right, let's see if we can get this other one to line up. It should work since these screws lined up with this housing. Guys, did we pull it off? Okay. Now the faceplate that came off the Super Cricket won't fit because the housings are different sizes. Right? I think they are. Will this fit? Now I want the other one. That's why. Has the right name on it. Let me clean this up a little bit. I don't want to do the inside in case it's got a coating on it, but let me clean the outside just a little bit. We're getting there. Okay, so I got the face polished up. Looks really good. It's not perfect, but for what you can see, it's pretty good. All right, so I'm going to put this on here, and we will see about getting this thing mounted. Get this set in the bottom like it should be. Okay, that little post is sitting at 6 o'clock. Pretty close to what that is. I'm looking to see the stop does not block it from getting to 0. And don't want it to block getting to the full scale either, so this is a good time to check it. I'm using this so there's nothing magnetic, although it's got plenty of own magnetism. Yeah, it'll go full scale. And it comes back here pretty good. Yeah, the stops are not in the way. Okay. And let's see if we can get that right dead center. Okay, dead center. All right, let's put the cover on. The needle is on the face. I wonder if I've got static from me wiping it down. Yeah, so it didn't have static on here. The needle was still up a little bit from my misadventure, so I just took a little bit of wire and put it up underneath here and just gave it a little bit of push down. And now I think that's good. Okay, so we can get this on. Aligning this adjustment point here. You guys don't know. With that little saddle that's there. Okay. We got the metal faceplates a little crooked on here. See if we can correct that. Yeah, so the card ran out of memory. I had to go in there and dump some files off of it. But I got this thing snapped back in there, and the needle works fine on its own. It's not dragging. Okay, so I guess I'll get it mechanically zeroed. It looks like it's right on. Not sure this will work. Yeah, it'll go the other way. It'll go left, so the travel stop is fine. And go like this way. Good. Get it on 0. Can have to go a little too far sometimes. Okay, that's good enough. Okay, so the question I have is, I wish that I had put a dot of red paint on the back of this here, so when I pulled it out, I didn't lose track of which one it was. I put it back in by the way the wires were laying, so hopefully that'll work. So what I want to do is test this with a very small amount of current. And I think what I'm going to do is use this itself. I'm going to put the filament voltage all the way down to the bottom. Okay, so that'll be very low, and then what I'll do is use some leads and just kind of touch it and see if the needle moves in the correct direction before I hook it up hard. So let me just get a couple of leads here. So I'll put that here, cut on this little light. Okay, and this one connects to the positive lead. And I'll just touch it here. All right, so let's see. Okay. And turn this on. Go to filament set. And I'm going to touch it to the positive lead, or what I hope is a positive lead, and see if it moves in the correct direction. Yes, it does. Go up to 2 volts. Good. Clamp it on. Let's go to line volts. It seems a little high, doesn't it? Let's see. Let me put the meter on it. Hold on. All right, so power on. This goes to here. Switch this on. Oops, go on. Go to line volts, and then if I go to 115 here, okay, 115, I want to zero that up at 100, what was it, 115? Yeah, 115. All right, so here we go. Got shocked a little bit. Nobody panic. Let's see, where was it supposed to go? right about there. Do you see that okay? Yeah. All right. Okay, so now go to, up to 120. Oops, that's too high. That right here. And there it's just a little bit over 120, 121. Okay. So I go to filament set. And then I go to 6. Okay, I don't have the load on it. Okay, let me get the load on it. Okay, can you see that okay? Almost. Okay, now we want to turn this to 6.3, so turn that to 6. And turn this to 0.3. Okay, it's a little north of where it's supposed to be reading. Looks like it's reading 7 here. This will vary a little bit, but won't make much difference. And here, then I have to just tweak this back up. Okay, it's reading 7 here. Yeah, it's reading 7 volts. If I turn this down to where it's at the red mark, it's at 5.65. Okay, well if I turn this to where it's reading what I think is supposed to be correct at 6.3, this is reading 5.6. Alright, well at least we got another meter, and then we'll look at maybe adjusting some of the we're going to look at adjusting that shunt path. I may also go back in and put those other resistors in that were part of the spec configuration, but we'll see. But looks like this meter is going to work. Now we just see if we can get it to read correctly. So I dug through my stash and I had a potentiometer, a 500 ohm linear. So I think what I can do is I've got it hooked up here, and it seems to work just fine. And I think I can put this in the place of that 480 ohm calibration resistor, and then use this as like a way to tweak the reading on the meter to where we can get a look at what range of resistances here get us a usable reading on the meter that's, you know, close enough to what we need. I'm sure 6.3 has a tolerance on it. I don't know if it's plus or minus 10% or whatever. If I assume 10%, then I could look at what ranges of resistance would it take for that calibration resistor to give us the right reading. So what I would do is go to each extreme and then disconnect and then measure the resistance on this, and go to the other one, find it, measure the resistance on this, and then find a resistor I've got that I can pick to put in that general range, and use that to replace the 480 that's in there. And then that should hopefully correct the shunt resistance for the use of this in these other positions. And then we'll get the meter squared away, we can check out the rest of the circuit. So I'm going to try to get that wired in, we'll run the test, and we'll see how that works out. Okay, so I pulled out the 480 ohm calibration resistor, because our goal is to try to find out what would make a better calibration resistor for this particular meter. So I pulled it out, and I've got 2 pigtails coming out that are soldered into the position on the board where they are. I'm going to clip in some leads that'll go to that potentiometer, and then we'll try to tune this to get the right view on the meter. Then I'll take some resistance measurements of the range of where that pot is, and then I'll come up with a replacement resistor, or maybe piggyback, or put some in series to where I get the right resistance for that. And then hopefully that will clear up the meter reading correctly on line volt, and then also it'll clear up the readings of the meter in the other positions that are on the test side of its circuit. It's not. I don't think it's really used on the rejuvenation side. So anyway, next thing to do now is take our freshly redone meter and let's get it installed. Okay, see a close-up of it. I'll need to readjust it, and then I'll put it back into the case, and I'll get this secured, and hopefully that will keep it safe. And then we'll move on and do that test. So I'll bring it right back. I need to use 2 hands for this. Okay, we got our meter back in, and we're going to hook up some leads to this. I need to make sure these don't come loose, right? Because if they come loose, that means there's no bypass. There's nothing bypassing the meter, and so it'll put the full current through there rather than part of it going through this shunt. And of course, I'll had to be ready to shut it off if that happens, but just make sure these don't come loose and fall off. So those look pretty good. Okay, I'm going to get everything else set up, and then we'll do our test. We need to readjust our meter for line volts, and then we'll see how this operation works. It'll probably be pretty delicate, I'm thinking. Okay, get this set up and we'll get going. Okay, so I've got the potentiometer set up here, and I've got it kind of tuned in to be close to 480. It's very sensitive. I put a knob on it here to make it a little bit easier for me to turn. It's going to be really sensitive. I have to be really careful. And, you know, this might be all just kind of futile, to be honest, because I was looking at, you know, I pulled up a service manual on a television set that I have in my project list, and I was just checking. You know, if you look at the voltages that are in the schematic, it doesn't. You know, it'll give voltages, but it'll say that all resistances are 10% unless shown otherwise. It didn't say anything about voltage. There's a few instances where it put a little flag, and it would mean 20%, but the rest of them are 10%. So I was thinking, well, really, then that means we're supposed to be at 6.3 volts on the filament, or the heater, how do you want to say it? This is a heater really, but this is filament. And so if it's plus or minus 10%, then here's what we're looking at. So here is, make sure you can see this. So here is your nominal at 6.3 volts. And if you go plus or minus 10%, that's the voltage range. Now earlier I did a test where I turned this to read 6.3, and I was measuring 565, a little bit under 10%. It's probably within how much I tweaked. If I turned it to the high side of that red line, it might have been fine. So what I'm going to do is just kind of be realistic about how much of a range we need to be really worried about here. So what we're going to do is try to run this test and see if we can get it kind of close. But I suspect, you know, we may end up just being hand picking some resistors that are really close in that area. But anyway, let's just run the test, see what we get. I just need to be real careful for the sake of our meter. Okay, so we got this set. I was wondering a little bit in it. We want this to be as close to 480 as we can get it, because that's in the ballpark of where we want it to be. Okay, I'll get the rest of this set up and then we'll get back and get the test. I got to put the load on the filament line. Okay, we're ready to go. I did the mechanical 0 of this already by tuning that, so I'll get that pointed at 0. We'll set it up to do the line volt first so that we can then do the 115 volt line here, and then we'll switch over to filament. I have the filament set down at 1 volt, so I'm not putting so much heat into my my load here until we're ready, but I do have this in the circuit. I don't have a way to measure it while I'm tuning it. Okay, no time like the present. Let's get going. So put this on. We're up to 120 volts. All right, so we want to, I'll go ahead and turn this on. We'll see this move. Good. Now we want to turn this to 115. This is not going through the shunt yet, because this particular switch hasn't engaged the shunt. Okay, that's really close enough. And this is right on, okay? Maybe a little off. Let me make just a little bit of a tweak on that. This is silly to be this close, I know. Okay, that's right at 115. All right, I think we're ready. I'm going to go ahead and flip the switch, and we'll start to see this come up to read 1-ish volts until I turn the filament up, and then we'll see this move. So we'll switch this to fill set. It's down low like we'd want it to be. 1 volt, 2 volt. See, it's happening over here. Meter's coming up. 4. That's 4. That's 6. Okay. So now what we want to do, I guess put fill set on middle stroke. How about that? Put that on middle. Now we need this to say, sorry, that needs to say 6.3. Can you see that okay? Yeah. Now that needs to say 6.3. We're just a little high. All right, let's see if I can make it not go crazy here. I just want it to move a little bit. This is working out pretty good. I think that's about it. Tweak this just because I'm anal. Okay, 6.3. Come on. 6.3. Okay, and we're right on the line. Okay, what I'm going to do is I'm going to shut it off and measure what the potentiometer is right there. Okay, so to do that, disconnect my meter, switch it to ohmage, disconnect one of these guys, and then we will measure its resistance. $461, huh? Okay. So to be on nominal, is 460 ohms for the shunt. Okay, what were we going to do? We're going to say, well, let's go plus or minus 10%. Okay, we'll do it that way. We should be able to do that. Okay, so I need to switch this back. So that comes off, and that comes off. Put this back on our load. You take this and put it on here. Switch this to AC. Okay, so what am I going to do? I want to tune this to be, let's just see. Power comes on. Turn this power on. We're at 6.3, and that's reading correctly. So if we went down to say, how about, instead of going all the way down to 6.67, how about we go to 5.75, something like that. So let's go to 5.75. So we went to 5.75. Okay. So if we're at 5.75 volts, real, okay, so what we'll do is we'll look at, if we look at the actual volts on the load, I had nominal and at 575, this is how many ohms to go to the meter to be on the red line. Okay, so now what we're going to do is we're at 575 and we'll adjust this to where it reads on the red line. Okay, So that would mean to take this guy and turn it just a little bit up. There we go. Okay, it's on the red line. I'm going to turn it off. And we'll measure that resistance for the shunt. Okay, that's off. It goes on. And this goes here, and this goes here. Okay. So we're at 530 ohms. So if the actual voltage is 575 and we've adjusted the meter to be on the 6.3 line, this would be the shunt resistance. So you see we're building a bracket to know where we need to be, how close to 460 we need to be. Okay, so now we'll switch this back. Got to go back to the load. And we need to put this back onto here without fail. Okay, switch that to AC. And now what we'll do is we'll go to, what do you want to say, 6 point, let's see, if I went to 7.5, then that's like 8. So how about we go to 6.85. 6.85. Okay, so what we're going to do is turn on the power. Make sure this is on. Yep. Okay, power on. And we want to adjust this to be at 6.85 into the load. Am I doing this right? If not, I can redo it. I think that's about as high as I'm going to be able to go anyway. Okay, I'm peaked out there at the top. I don't want to be that high, so I'm going to go right here. So that is at 6.5. So 6.5 volts. Let's see, 6.5. And now we'll tweak this to be right on the red line. Right about there. Okay, turn it off. And now I'll measure the resistance. Okay. 444, call it 445 ohms. Okay, so that means that nominally we'd like to be as close to 460 as we can, and our range can be somewhere in between here and here. So we want to be 460, but certainly within here. So we'll go find a resistor that we can pick, and then that'll be our resistor. And the closest we can get to 460, the better off we'll be. So I've been sitting here shaking my head, thinking, what did I just do? So I just said, okay, what we'd like is an ideal 460, but really what we'd like is to be nominal 460 as close as we can get it, but as long as it's between 445 and 530, then we will stay within the plus or minus 10% on the 6.3, right? Well, the closest thing I could find to that was the resistor that was in there, 480. So I've put the 480 back into here, and it measures right at 430. It's a 1% resistor. I've got this tuned to 6.3 actual volts going through this load, okay? And so now what I'm going to do is look at what this is reading. And it's reading a little high. I think I said it was reading 7 before. It's not reading that high now. Maybe I don't have good connection on my clips. But if I tune that to be 6.3, using the fill set, if I was using this to set up the test, right? And I went right there, I'd be at 6.13. And I guess the realization that we have is 6.13 is well within the plus or minus 10%. Okay? See, that's even within 5%. So I guess this is a waste of time, but I guess what we did is we verified that the amount of difference that this is off is within the tolerance of what is on the heater. And we wouldn't have known that, though, if we didn't go through this test to find out what is the actual we're getting here. And, basically validating that this is a good resistor for the shunt line. So this is going back in, and then we'll come it back. And just for my reference, going back, have it on filament set, have it at 6 volts, going for 6.3 into the load. I adjust this for 6.3. Okay. I'm into the load. So I'm at 6.22. That's an error of, so that's 0.08 off, right? Divided by 6.3. So that makes me 1.2% out. I just happened to notice when I went looking for some other information. Open this thing up. In here it has meter accuracy for the filament voltage. We're less than 2%. I'm happy finally. Good. All right, so meters replaced. I think this unit is back in working condition. I'll go through and check a few more things. I'm not going to bore you with any more of this. I think the only other thing really I can check is the HK shorts has a calibration, and then there's a calibration also for if you get into rejuvenation, how long it pulses a higher voltage and comes back and pulses again. You can set the duty cycle, if you will, of the on and then the off. They're separate controls. I'm not planning on doing that anyway, so I'm probably not gonna bother with it. But I'll check the HK shorts calibration. But other than that, I think we're just about done. I'll bring you back when we're all basically done with that. If I find something interesting, I'll let you know. Okay, guys, so it looks like we got the meter working, and I think this thing is doing really well. We've got a few things left to go, and I mentioned if I found something interesting, I would let you know. So, yes, I found something interesting. Very interesting, in fact. It's downright diabolical. So we will go into that in the next part. And this time it's not my fault. You'll be interested to see what it was. So anyway, in this one here, we spent a lot of time working on how to get the meter replaced. The one that was in there appears to be damaged. I really can't seem to get it to operate. So I looked at using first a meter with a 200 microamp scale, just to see if the circuit was behaving correctly. Then I tried using a couple of other meters, and they just didn't work out right. So I ended up cannibalizing a Sencore, a Dixon, I guess, meter from another Sencore unit, Super Cricket, and then moved it over to the housing and the faceplate for the Super Mack and got it to work. I spent a lot of time dealing with the issue of adjusting the shunt for a given ammeter. I guess I had kind of a blind spot in terms of thinking that they all kind of had the same, impedance, but they might have a different spring force or whatever. But in reality, no, they didn't. And I think in hindsight, I think I knew this way back in my mind from back when I took classes in this sort of thing. I do remember, it seems like there was something like all meters are ammeters or something like that. Anyway, I think I had a little bit of target fixation, not really in the way motorcyclists or cyclists ride into a hazard, but more like kind of in the pilot world, you get kind of a target fixation when you think about something specific that you have as a task in front of you, and you kind of lose situational awareness, and your brain kind of shuts off when you're getting plenty of clues that something else is going on. And you heard me thinking out loud, is this got a different impedance? There's my brain trying to wake me up out of my very purposeful following of troubleshooting charts. So here is one of the pages of the troubleshooting chart in the manual. And we get down here and we see, does the meter M1 read proper filament voltages? Okay, well, to my engineering mind, this is kind of like, oh boy, I just follow the chart, and my consciousness kind of turns the brain off, I guess. So I started following the logic of this, what was going on and what kind of readings were we getting. I'd go to the next page, and let's see if I can get this where you can see it. Yeah, so conclusion, replace M1. It just stops at that. Well, it means replace M1 with the exact same part number. If you don't, you've got to go in and make an adjustment to that calibration resistor. You got to adjust your shunt. Now, where they had the potentiometer on the power supply board, that's what that's doing. They should have had it, in hindsight, I think it'd been nice if they'd had a VR on the shunt line for that 480 that we were looking at, so that we could tweak that in as well. If they had said replace M1 and readjust shunt, I would have been done. Okay, but instead, it got me running off to other things like, well, I did that and it didn't help. So then it has me go over here and check, the wiring, go into those switches and to that resistor and these two diodes. Those two switching diodes I was looking at, and that R220. I think that's one of those precision resistors that I replaced with the carbon comp. But anyway, I was in here looking at the shunt circuit instead of realizing that, hey man, you place the meter, you got to go through and adjust the shunt. And I kind of turned my brain off on that. But it was interesting, I think, to see my old brain remember or learn, what happened there. And it was interesting. So once we did that, we got that back into place. But anyway, like I said, we went forward with this and we ran into something interesting. So there's going to be a part 3, and it's an interesting one. All right, guys, thanks for watching. I appreciate it. Hope you got some enjoyment out of this, and I'll see you next time. Thanks. Bye.